Imagine a world where machines dream in vibrant colors, composing symphonies and painting masterpieces. This is the promise of diffusion models, a revolutionary AI technology. These models are transforming how we create and interact with digital content. Unlike anything we've seen before, they birth art, music, and even videos from the ethereal whispers of random noise. Diffusion models are not just tools for artists and musicians, they are powerful engines driving innovation in fields like medicine and scientific research. Imagine doctors using AI-generated images to diagnose diseases earlier and with greater accuracy. This is not science fiction. This is the reality unfolding before our very eyes. Join me as we journey into the heart of diffusion models, exploring their inner workings and the profound impact they are having on our world. Imagine a pristine canvas slowly being sprinkled with grains of sand. This is the first step in the magic of diffusion models, introducing noise. The process starts with a simple image, sound, or data pattern. Then, the model gradually adds noise, like scattering those grains of sand, until the original pattern is completely obscured. But here's the twist. Diffusion models don't stop there. They embark on a second journey, a reverse dance, meticulously removing the noise step by step. This denoising process is where the true magic happens. The model learns from the noisy data and begins to reconstruct the original pattern, but with a twist. Think of an artist sketching a portrait. They start with rough outlines, gradually refining the details until a masterpiece emerges. Similarly, diffusion models, through this denoising process, transform random noise into coherent, breathtaking creations. But how do they know which grains of sand to remove and in what order? That's where the power of sophisticated algorithms and massive datasets comes in. At the heart of diffusion models lies a beautiful symphony of mathematics, a language that speaks to the fundamental nature of order and chaos. One of the key players in this orchestra is the Markov chain Monte Carlo, MCMC method. Imagine a gambler moving between slot machines, their choices influenced by past wins and losses. Similarly, MCMC helps diffusion models navigate the vast landscape of possibilities during the denoising process. It guides the model, step by step, making decisions based on the current state of the noisy data and the desired outcome. Another crucial instrument in this mathematical symphony is the U-net architecture, a special type of neural network. Picture a vast network of interconnected neurons, each processing information and passing it along. U-net acts like a conductor, orchestrating the flow of information through this network, enabling the model to learn intricate patterns and relationships within the data. Through the harmonious interplay of MCMC and U-net, diffusion models achieve a level of sophistication and nuance previously unimaginable. These mathematical foundations empower them to generate high-quality outputs that rival and often surpass human creativity. The impact of diffusion models extends far beyond the realm of art and entertainment, reaching into the very fabric of our lives. In medicine, these models are revolutionizing diagnostics. Imagine a world where doctors can generate high-resolution images of organs with unprecedented detail, enabling earlier and more accurate diagnoses. Diffusion models are also transforming drug discovery. By generating countless molecular structures, they accelerate the search for new medications and therapies. In the realm of art and design, these models empower artists with new tools to express their creativity, generating stunning visuals and pushing the boundaries of imagination. But the story doesn't end there. Diffusion models are also making waves in video generation, creating realistic and immersive experiences that blur the line between the virtual and the real. Imagine stepping into a video game or a virtual world indistinguishable from reality. This is the future that diffusion models are helping to create.